Lesson 17, translating between words and algebraic expressions. Okay, so what we have here is we have a nice table that gives us some examples. We have words, phrases, and expressions. So we can say several different things to tell us that we're adding, subtracting, multiplying, or dividing. And so, for example, words for addition are the sum, finding the total, more than. If I have 3 more than 4, that means I'm going to add 3 to 4. Added, increased, and plus. So some example phrases they give us are 4 added to a number. So we're saying 4 right here is being added to a number. We don't know what number, so we just put X. Same for this one. 7 increased by a number. 7 is being increased by adding to it a number. We don't know what number because they just said a number. Same thing for subtraction. Some different words for subtraction are less, minus, decreased by, difference, less than. Those are all numbers that mean that we're going to subtract, or letters. Those are all words that mean we're going to subtract. The difference of 5 and a number the difference of 5 and a number. So whenever they say the difference of, okay, whenever we have the difference of, we know that we're subtracting because difference means to subtract. We write the problem in the order that we read it. 5 and a number. So it goes 5 and a number, and then we're subtracting because of the word difference. These are the ones that are sometimes tricky. It doesn't really bother us in addition because we have the commutative property of addition, but with subtraction it very much matters the order that we subtract. So whenever I say 8 less than a number, that means I'm subtracting 8 from the number, which is what I'm showing over here. This is 8 less than a number. Words for multiplication are product, times, and multiply. So we could say the product of a number in 6. That means that we're multiplying a number in 6, which is not what we're showing over here for some reason. So whenever we write this, we would write it in the order that we read it. A number and 6. Okay. Over here, a number times 3. This is a number being multiplied by 3. On this one, again, on all of this, because of the commutative property of multiplication, we can multiply in any order. Words for division are quotient, divided by, divided into. So we could say the quotient of a number in 6, this is like subtraction, we have to write it in the order that we read it. Quotient tells us that we're dividing. A number and 6 means that the number comes before 6, or the variable comes before 6. 10 divided by a number, this is showing 10 being divided by a number. So it says write an algebraic expression for each phrase. So on A we have X decreased by 7. That means that we're decreasing by 7, so we're subtracting 7. So we would show this as X minus 7. The product of 12 and N, that means that we're multiplying, so we could show 12 times N. On C, 3 less than means that I am subtracting 3. The quotient of Z and 24. Quotient tells me that I'm going to divide, and I have to write these numbers in this order. So Z divided by 24, I can show as Z divided by 24. I hope you agree with that because a fraction bar means the same thing as dividing. And then I have to have 3 less than this, so I'm going to say minus 3. Sylvia is 4 years younger than Omar, who is Y years old. Write an expression that shows Sylvia's age. Sylvia is 4 years younger than Omar. 4 years younger means that we would subtract 4 from Omar's age, who's Y years old. So we say Y minus 4, and that would give us Sylvia's age. Use words to write each algebraic expression in 2 different ways. I want you to go above and beyond here. Don't just say b plus 12. Give me some different things, okay? Some different ways of saying it. You can say that for one of them, but not for both of them. So go ahead and pause, and I want you to come up with 2 different ways to write into words what you see on your screen. Okay, on A, I have b plus 12. I could say that this is the sum of b and 12. 12, that's a 2, not an H. My pen froze. I could also say 12 added to b. On b, I could say p decreased by 7. I could say the difference of p and 7. Okay, on this one I could say the product of 21 and x, or I could say 21 times x. Over here I could say the quotient of y and 8. I could also say y divided by 8. And on the last one, I'm trying to give you a tricky one here. So first of all, we know that we're subtracting and we know that we are multiplying. So I could say, and this is supposed to be a fraction in case you didn't see that. This is 1/2 here. So I could say the difference of 10 and the product of 1/2 and 14. Okay, the difference of 10 in the product of 1/2 and 14. Okay, this is the difference. I'm subtracting this from this. Okay, I wrote it in the order, and then this is the product here. Okay, final one here. Jane has saved X dollars. Write an algebraic expression to represent the total amount of money she will have saved if she saves 75 per week for Y number of weeks. So I already know that she's saved X dollars. She's already got this much in the bank. And her goal is to save 75 a week for Y weeks. So every time she saves $75, she's going to be adding $75 to it. But she's doing it each week. So we're going to say 75Y, because I could plug in for 1 week, how much would she have saved? For 12 weeks, how much would she have saved? And I can do that math. So that's it for tonight. Make sure you're taking good notes. I'll see you in class tomorrow.